Determine the common difference, which is the sequence generator for each arithmetic sequence listed below. Then write the equation for the nth term for each sequence. Keep in mind the first term of each sequence is t at 1. So they're pointing out that these values, let me zoom this in quite a bit here. They're pointing out that these are not the 0th values, but these are the values produced when n equals the number 1. So let's go ahead and look. The first sequence, 4, 7, 10, 13, each of those are 3 more than the previous value. So let me make a little column here. And actually there's 1, 2, 3, 4 different problems. So this first column, I'm going to write down what the generator is. So I'm told they're all arithmetic, so I don't have to kind of go around and figure out if it's arithmetic, geometric, or something else. This is arithmetic, and I can see each time I'm just adding a value of 3. And let's do this for all of them. The next one, from 3 to 8, 8 to 13, each of those are, my generator is adding 5 each time. For the next one, I'm going from 24 down to 19, and then 19 down to 14. So on this one, each time we're subtracting 5, so we're adding the number -5. And then the last one there, 7, 8, 9, 8, 9.5. So 2.5, so each time we're adding 2.5. Let me see if that works with the next one. So if I'm at 9.5, I add a half, added the 0.5, I'm at 10, and then 11, 12, yeah. So each time there I'm adding 2.5. Now in order to kind of make this more simple, it's nice if I knew what the 0th term is. Remember the 0th term is not listed in the sequence. We always start a sequence at the first term. But the reason why we like to think about the 0th term is that's equivalent to the y-intercept. And if I know both the generator value, which is equivalent to the slope, and the y-intercept, it's pretty easy to write the rule for it. So for each of these, if I was to think about the 0th term, I guess I'll write a column for that. So for example, t at 0, well, that's just going to be the value 1 more before the one that I see starting with it. So you can see here, I'm starting with a 4. And if each time I'm adding through and as I go forward, right, if I was to back up 1 and get the 0th term, that would have to be the number 1. So t for the first, for a, t of 0 is 1. For the second one, you can see I'm at 3. And if I back up by subtracting 5 from that, I get that the 0th term would have to be the number -2. For the one before that, to go forward, I'm subtracting 5. So if I want to back up for the 0th term, I'm going to add 5. So t at 0 would be the number 24 plus 5 is 29. And then for the last one there, I'm at 7. And if I subtract 2.5, that would give me my 0th term is at 4.5. So for each of these now that I know the 0th term and I know the generator form, it's pretty easy to write the explicit equation, right? So for A, it's going to be t of n is equal to 3n and then just plus 1. And you can see for this here, the 3 is equivalent to the generator. The plus 3 is the generator. So I'm multiplying the generator by n each time as I move down the sequence. And also the, sorry about that. And also the 0th term is equivalent to the y-intercept. So let's just go ahead and write the rest of these, right? For the next one, t of n would equal 5n minus 2. And then t of n would equal -5n plus 29. And then finally, t of n would equal 2.5n. 2.5n, and then plus 4.5. Well, there we go. Those are our 4 explicit rules.